And our next presenter will be remote presenter Nicole James from FSU. And
Hello,
again,
thank you.
again, just a reminder, if you can put questions at Q&A, you can put that in at any time, and we'll address those, I guess, after our next speaker. Perfect. Looks good.
All right.
Take it away, Nicole.
Hi, thank you so much. My name is Nicole James. I'm a digital media researcher with iDigBio at Florida State University, and I have been exploring and utilizing 360-degree cameras in the field for capturing specimens of varying sizes. So I want to talk a little bit about 360-degree cameras as an omnidirectional multi-tool. So I want to contextualize 360 degrees first as a type of immersive media, and that simply means that this is media that leverages the 360-degree space and allows users to experience and interact with virtual content. And this can include camera-captured content from 360. So immersive media simply creates a more interactive experience, and this can be accessed through mobile devices, virtual reality headsets, or physical sensory spaces. And users get the impression that they are embedded within the scene, and this is accomplished through something called degrees of freedom. So your 3 degrees of freedom allows you to look around a space, while your 6 degrees of freedom allows you to look around a space, but also approach and get closer to objects in that space and interact with them. And 360 is often compared with virtual reality, but this distinction between degrees of freedom is where they start to set apart. So the 360-degree experience is limited to the movement and location of a camera. So there's only 3 degrees of freedom and limited viewer interactivity with a scene or space. And this includes the length of a video. So rather than a computer-generated 6 degrees of freedom environment, 360 immerses the viewer in a real-world video or photograph. And this camera-captured content can be accessed through virtual reality headsets, but it's not required. So you can access this through your mobile device, that physical space, or simply through online host sites that have navigation tools embedded within them, such as YouTube. So here's an example from the Florida Coral Reef diving experience. And you'll notice here that I'm able to click and drag the frame from left to right. And we can notice that we're moving with a marker. So we are moving with the camera in this coral reef, which is operated by our diver here. And while I cannot access or get closer to the schools of fish or go out and explore the reef, I can at least reorient my camera to what I want to focus on. So what is 360 adding here in addition to our traditional imaging? Well, if we were to capture a habitat such as the reef, we would have to take an image in a single lens mode like so, then change the angle, take another, change the angle, take another, and then eventually make it all the way around and then compile a sense of that space. And while this can bring helpful documentation, it's inadequate for capturing the kinetic nature of something such as a coral reef or an active environment. So the omnidirectional shooting of 360 grants a more accurate representation of the biodiversity at a single moment in time. And many 360 cameras are able to vary their capture mode. And because they were originally designed as action cameras, you can see here, this is fully waterproof, and most are, but at the very least, they're water resistant, they're durable, which makes them well designed to be taken out into various terrain for environmental capture. If you did have a headset, which is nice, you could look around this space from YouTube, but because of that variable mode of being able to view 360, you have different options depending on what technology you have as a user. And what's really great about these cameras for capturing this content is that they are largely cost-effective. So currently I'm using a consumer grade camera, the Insta360 X3. This is a completely waterproof camera that can be submerged 33 feet in the water. It can shoot in 5.7K for 360. It has built-in stabilization and stitching. And many of the consumer grade models will have comparable features as well. Once you start getting into professional grade cameras, you can range well beyond $5,000, but this would include your 8K shooting capabilities and above, larger camera sensors, deep dive capabilities, and more than 2 lenses on the camera. So 360-degree cameras capture their content by combining imagery and video from 2 or more lenses. And I mentioned internal stitching. So this is the 360 that I've been using, this X3. So you'll notice there's a lens on either side, and then it would stitch up the middle. And so this camera is really compact, and I was able to take a simple camera clip here and attach it to the inside of a cherry blossom tree in bloom here in Virginia. And I'm able to take a look at the active pollinators flying around from blossom to blossom. And what's really nice about these 360 cameras is that not only can they shoot in 360 like so, but they are able to shoot in different modes, such as a single lens mode, time lapse, and they include similar setting changes to traditional cameras, like changing your frame rate, your resolution, ISO, white balance. And they also often include specialized modes for tracking GPS data, or you can connect them to your mobile device to control them from afar, which is what I'm doing here. So I was able to place the camera in a really interesting point of view from the inside of this tree, step away, and allow the pollinators to come back and fly right by the camera. And this here is an example of a still extracted from this video. So this is what 360 looks like stretched out. So you can see where this gate would connect over here to the other gate to create that single frame. And these cameras have been used for a number of research applications, including reconstructing 3D models, mapping route behavior from the back of a shark, conducting non-destructive monitoring of species, and applying this data to conduct observational training in virtual reality headsets. And these images have also been combined with machine learning to help detect plant growth, detect trees at field sites, and entire classes and events have been documented to be experienced in 360, which makes them more accessible and able to be revisited. And this data has also been used in architectural conservation to identify and monitor deterioration mechanisms. And this can include using 360 images as a base for a virtual tour, where you can embed information such as 3D models so that you can use a more active site within 360 to share embedded data. And here's an example of this from the University of South Florida's Center for Digital Heritage and Geospatial Information. So I'm able to look around the images and anchor points within this virtual tour, but I'm also able to click on these animations and interact with embedded media. So while using these as a host, I'm still getting an idea of the space, and I can also look at more spaces within the map here in the top left corner. But this can serve as a host where you can interact with 3D models, text, audio, standard video, and images, all while situating this information spatially within a given environment. So even though we're remaining in our 3 degrees of freedom, we are adding interactivity for not only outreach, but this could also be used as a virtual field log that could help contain and visualize research information. And what I've been working on is I have been applying 360-degree camera use for capturing specimen collection sites and experimenting with best practices for utilizing these devices. So I've been mostly focusing on capture methods and patterns on the ground to best document varying sizes of specimens, such as small flowers to these 2 trees in bloom. So I've been exploring how these video and images can not only add missing context, like situating them inside a tree within the cherry blossoms, but also using this visual data post-capture. So this would include the 2 3D models you see here that I've created via Agisoft Metashape. So I've taken stills extracted from 2 360 videos, and this is one of them, to then create a virtual model. So I'm leveraging our 3 degrees of freedom here in our 360, and then I've even converted it into 6 degrees of freedom with our 3D models. Rough 3D models, but still gathering that spatial data. And while 360 is great, some challenges in utilizing the cameras include that imperfect stitching. So the more lenses you have in cameras, the more problems. I've noticed this in my work, particularly with complex patterns, overlaps, or when they are closer to the camera, it starts to struggle with that stitching here. As I tried to capture this cardinal, you'll notice those branches didn't quite overlap perfectly, so I'm working through best practices to avoid that as well. And common issues with 360 overall include file size and hosting needs for the files themselves. This technology is constantly updating, improving, and changing for better or for worse, but that also means needing to update and acquire proper software to view and host them. And some consumer options, including the X3 that I've been working with, still struggle in lower light conditions, and this is partially due to the trade-off for them being more user-friendly. So some of those manual capabilities available with DSLRs are not available, or they're unable to be changed as they would be otherwise. And that is a very quick rundown and update of how 360-degree cameras can be applied to the collections community and what I have been working on here. Thanks so much.
Great, thank you, Nicole. That was great. Up next is Duncan Urshik from UMass Amherst. And again, as a reminder, you can add